Hi, good afternoon. My name is Darren Knoll, and this is a demonstration of my 697 Senior Capstone Design project. What I'm going to be showing is a working prototype of a ESP32-based Wi-Fi sniffer that is communicating with my laptop computer through Bluetooth to transmit captured probe request signals. And we're going to then process that data on my laptop, capturing it through a Python script and performing all of the cleaning and structuring of that data in Python as well. So to start with, I'll just show a quick shot of the prototype in action. At the moment, it is, apologies, being worked with for the sake of a current measurement. So right now, the baby buck converter is sitting on the back of this Vero board, and these two clips are connecting the voltage input of this battery terminal, which is a 4 AA battery pack, and the output of this baby buck converter is then being fed here to ground and the out, which is 3.3 volts here. So all of the voltage or all of the power is being supplied on these rails to these various Wi-Fi sniffers. And these are the sniffing devices. These are ESP8266s, and this ESP32 is the host that receives the data on UART and then passes that data through Bluetooth, which is built into the chip. So to just show it in operation, I'll go ahead and start this current meter so we can witness or just observe the current output that takes place while this is connected. So this is now on, and we can then see it should be a current measurement. Perhaps it's out of range. Yes, out of range. So currently it's about 175 milliamps. And once I connect with my laptop device, we will see, apologies, this is a bit of a tunnel vision. Oh, okay. We'll just have it up here. So just open up TerraTerm, which is a terminal, and connect to this virtual terminal on port 12. You can see the output now feeding. I'm going to move it up to this screen. And when I walk back, you can actually see that the power consumption has increased because it is now communicating over Bluetooth to about 200 milliamps. So now I'm going to move over to a screen capture. Bear with me. So on this screen, we're witnessing the terminal input here as the different sniffers are collecting the data. I'm going to actually close this out so we can actually get working with the stream set from Python. So this is the capture script, which I'll first run. I believe this is all set up correctly. So we'll run it for about 30 seconds. Actually, I'll do a bit shorter for the sake of our demo here. 10 seconds shorter, 20 seconds, and we'll run it. So it is currently running. We see the printed output, the serial data. It's not going to be a whole lot given it's only 20 seconds, but once we have that complete, it should make a little message. Wonderful. And so we can actually just see from the stream that most of the data came in pretty well, but there are a couple of failed transmissions. So within here, I have first a way to parse the data here in the stream cleaner script. So I'm going to, this has all been overwritten, that's okay. I'm going to go ahead and do demo, and I'm going to actually write demo 2 clean just so that I can keep my other working script or Excel sheet. So go ahead and write that, and that already cleans it all up. And then I want to import it here, demo 2 clean. You can see that any bad lines, as it says here, if there's anything that doesn't make sense with the number of rows and columns that are expected, it will just discard those. So some of the erroneous transmissions will be cleaned up that way. In addition, I go through and check and make sure that all the fields are as expected in terms of their formatting and what kind of data they contain, and cast them into the correct types, data types. This is all working with Panda's data frame API. And I'm able to then create a small report. And also show a scatter plot of the sequence numbers. So let's go ahead and try that. All right, so here are some of the trail of sequence numbers. We look at this as a form of understanding trend lines, and it's more meaningful when there's, of course, more labels, but this is just where I was able to take the project. And if I go and find demo 2 report, the number of unique frame lengths is 16, which are printed out here. So those are the unique frame lengths that were captured within the 227 probe requests that I transmitted from this streamer. And the implications of this project is that we can then analyze this data further to understand the amount of devices and ergo people that we're passing through a given space, and coupling that with the received signal strength index, known as RSSI, is a form of understanding how that device moved through the space, which is what the overall goal of my research is. And I hope that this device will aid me greatly in doing that. So thank you again so much for coming and hearing about my 697 design project.